Let's study now some properties of the logarithmic functions and see how we can apply this to compute derivative easier. So the first three properties that we will see is that the logarithm of a product is the sum of the logarithm. So the logarithm transforms a product into a sum. Also, a logarithm converts a division, so m over n, into the subtraction of logarithm. So if we have logarithm of m over n, it is equal to the logarithm of n minus the logarithm of n. Finally, the third property is that if we have the logarithm of m to a certain power p, then we can take p outside. So logarithm of m to the p is p times the logarithm. So let's try to use this in our example. So in this case, we have to find the derivative of this complicated function, right? So if this was any other function, we will have to use the chain rule, and after that, we will have to use the product rule and stuff like that. So let's see if we can use the properties to simplify our task. So the first thing we will do is that this is equal to, using property number 1, to the logarithm of x cubed plus the logarithm of x minus 1 to the 11th power. So notice that we had a product, x cubed times x minus 1 to the 11, and we separated it into sums. Secondly, we can see that this function is equal to 3 times the logarithm of x. This is simply by using property number 2, plus 11 times the logarithm of x minus 1. So now our problem is way simpler than before. So now we can compute this derivative simply by following the rules. So this is 3 times 1 over x, and in the second case we have to use the chain rule with the function x minus 1. So we have a logarithm composed with the function x minus 1. So this will be 1 over x minus 1 times 1. So this is simply equal to 3 over x plus 11 over x minus 1. So computing derivatives using the logarithm is very friendly. You can separate all the products and divisions and powers and convert this into just sums and differences of logarithm. The final property we will see is what is called the base change. So here we have that the logarithm with base a of x can be written in terms of the natural logarithm. This is the logarithm with base a of x will be equal to the logarithm of x divided by the natural logarithm of a. So something to keep in mind is that this number on the denominator, this is a constant. So this is saying that the natural logarithm and the logarithm with any other base are almost the same except for a constant, which is equal to the natural logarithm of a. So let's use this to find the derivative of this logarithm. So using this property, we can find that f of x, which is equal to the logarithm with base a of x, it's equal to the natural logarithm of x divided by the natural logarithm of a. This again is property number 4. So now if we want to find the derivative of this, well, remember that this number now is a constant. So if we take the derivative, we can take it out. So this is the 1 over the natural logarithm of a times the derivative of the natural logarithm, which we already know how to compute. This is just 1 over x. And we can put this together to say that the derivative of the logarithm with base a is 1 over the logarithm of a times x.